we're now going to use Pythagoras to prove another identity. There's three we can come up with. I'm going to go through one, and then I'm going to let you have a go at one of the other ones. And so we'll go through this, and then I'll pause it, and you can have a go at some of the others. So we've got Pythagoras. We know Pythagoras' theorem for a right-angled triangle. A squared plus b squared equals c squared. We know that's true. So what we do is we take this a squared plus b squared equals c squared, and we divide by one of the things, c squared, and it's going to give us an identity. And then we could come back to this and divide by not c squared but b squared, and then we can do a third one where we divide by a squared, and they give us three different identities. So let me show how one of them works. If I divide through by c squared, I divide every term by c squared, I get this, look, a squared over c squared plus b squared over c squared equals 1, because c squared over c squared is just 1. Now what we do is we say, okay, instead of writing it as a squared over c squared, I can write it as a over c all squared plus b over c all squared equals 1. But if we think of our right-angled triangle, let's just draw it here so we can look at it. You've got it on your page anyway. If there's the right-angled triangle, let me write it the same way around as it is there to avoid confusion. So if we look at this right-angled triangle, where that's A, that's B, and that's C, and this is theta, I've still written it the wrong way around. So carrying on, if we look at this, what's A over C? Well, A over C, if that's the angle theta, A is the adjacent, C is the hypotenuse, adjacent over hypotenuse is cos theta. So instead of writing A over C, I can write cos theta. Similarly, B over C, for this triangle, B is the opposite, C is the hypotenuse, opposite over hypotenuse is sine. So instead of writing opposite over hypotenuse, or B over C, I can write sine theta. So I can say that the cos of theta all squared plus the sine of theta all squared equals 1. Note this. When we write down this identity, Jordan, you're now enshrined in the video, cos theta squared, I write that in shorthand as cos squared theta. So cos squared theta means the cos of theta all squared. Sine squared theta means the sine of theta all squared equals 1. And that's a trigonometric identity. If I get the cos of theta and square it, and the sine of theta and square it, they'll always equal 1 if I add them together. A trigonometric identity. How did I get this identity? By dividing through by c squared to get this, and then thinking about what A over C is in terms of the triangle, and what B over C is in terms of the triangle. And then writing down an identity. So what I'm going to do now is ask you to divide this, which is Pythagoras, go back to here again, divide through by b squared, and see what you get. Try and come up with another identity, and then if you've done that one, divide through by a squared. You'll end up with 3 identities. So I'll stop this, and then we'll look at them on the next video.